We have booster ignition and liftoff of Columbia, reaching new heights for women in X-ray astronomy.
The main thing Chandra does is take these superb, sharp images.
Astronomers think that a supernova should go off in our own Milky Way galaxy every 50 years or so. When was the last one we've seen? Probably 1604. Yes, that's over 400 years ago. This being astronomy, however, things will undoubtedly average out over the long run. But in the meantime, we're left without a recent supernova in our galaxy to study. Luckily for us, astronomers from previous centuries were on the case. By combining information gathered from sky watchers from ancient times with the tools available in modern science, astronomers can learn some really crucial science. Dr. Tracy Delaney of the Massachusetts Institute of Technology studies supernova remnants with a variety of telescopes, including the Chandra X-ray Observatory. She explains why these so-called historic supernovas and the remnants they create are so important to our current understanding.
The advantage of having supernova remnants in our own galaxy is that they are nearby, so that we can see details that would be smeared out if they were farther away. In nearby remnants, we can see the actual interaction of the explosion ejecta with the massive wind from the star. We can see that these different components emit in different wavelengths of light, such as optical, radio, infrared, and X-rays, and we can see that they have different chemical compositions and different motions.
Since this work relies on history, it's often hard to know how reliable the connection is between these ancient reports and what astronomers see today. And remember, all except one of these supernovas was seen before the invention of the telescope in the early 1600s. Despite that fact, there is some really strong evidence for when these supernovas went off. For example, there's Tycho supernova remnant. This one was discovered by Tycho Brahe in Denmark in 1572. The Kepler supernova was reported by many people, including the famous astronomer, you might have guessed it, Johannes Kepler. Tracy Delaney explains how today's astronomers benefit from having these reliable supernova birthdays.
One thing that is really interesting, if there's a neutron star left behind after the explosion, knowing the explosion date is critical. Some neutron stars receive a birth kick from the explosion, so we can determine how fast and which direction they are moving. If we have a spinning neutron star, a pulsar, then we can determine how rapidly this pulsar was spinning at birth. We can also determine how much the neutron star has cooled since birth. This in particular is kind of neat because neutron stars have superfluid interiors under conditions that we cannot replicate in laboratories on Earth. Understanding how neutron stars cool helps us study superfluids, which are an interesting and mysterious state of matter.
Just as there are some really strong cases, there are others that are more tenuous. For example, the most recent supernova to go off is believed to be Cassiopeia A, but the records from the early 1600s are conflicting, so no one knows for sure what year it actually exploded. Others, such as RCW 86, G11, and G347, have evidence from Chinese astronomers, but the links are not always ironclad. Tracy Delaney talks about how such uncertainties in the historical records present challenges to those who are trying to study these supernovas today.
In most cases, there is still much that can be learned about supernova remnants when the explosion date isn't known. We can still determine how the different emissions are related to each other and how each moves with respect to the other. We can measure ejecta expansion rates, neutron star motions, and pulsar spin periods and estimate ages from there. In some cases, there is debate about whether a remnant and a nearby neutron star are related. There could just be a chance alignment on the sky, but the objects could be very far apart.
These supernova remnants are obviously some of Chandra's most beautiful images, but they are so much more. Astronomers have been waiting centuries for the next supernova to go off in our own galaxy. In the meantime, they combine history with astronomy, two fields not often associated with each other, to help us understand a little bit better how stars die. For more information, visit our website at chandra.harvard.edu.
This was a production of the Chandra X-ray Center, Cambridge, Massachusetts. NASA's Marshall Space Flight Center manages the Chandra program. The Smithsonian Astrophysical Observatory controls science and flight operations from the Chandra X-ray Center.